Welcome to today's episode. This is Danjin. You can also call me Dan. I'm working on a series of functions. We are finding the Laplace transform of these functions. If this is your first time, please locate videos under Laplace transform in this same playlist. There is an introduction to Laplace transformation in the first video. You should watch that one to get the concept. So we have hyperbolic functions in this one. I'm working on Coshat. In the next video, I'll work on Sanh 80. So we know that the Laplace transform of a function f of t is given by L f of t equal to the integral from 0 to infinity. We have f of t times e minus st dt. If you look at my introduction to Laplace transforms, I explained the meaning of these variables. So I've done those explanations there. Please look at it for the sake of those of you who are seeing this for the first time. We have the function f of t equal to this. So all we need to do is to substitute Coshat here. So we have the Laplace transform of Coshat being equal to the integral from 0 to infinity. We put in our Coshat times our e minus st dt. Okay, but note that in hyperbolic function, Coshat has a definition, so I will put it here. We know that cos t, let me work with 80, so I'm working with cos 80. So cos 80 is equal to the exponential function 80 plus e raised to the power minus 80 all over 2. Some people you can also put it as 1 out of 2 times e raised to the power 80 plus e raised to the power minus 80. Okay, so we can also use this one. So now let's focus on the first one. So we just substitute this one to represent cos 80 and we can continue with the calculation. E to 80 plus e to the power negative 80. We divide this one by 2 and we multiply by this one. We have e to the power negative st dt. Okay, so from here we can now factorize the 1 over 2 out like I did here. So we can just factorize it outside by getting 1 out of 2 integral from 0 to this. And then we have e to 80 plus e to minus 80. Close your bracket and multiply by negative st dt. Okay, so now we have a linear function. We use this to multiply this and that. Then we expand and we integrate. Okay, so we are having 1 out of 2 integral from 0 to infinity. This time we are having e to the power negative st times e to the power 80. Okay, this time I just decided to write e to the power negative st first. Okay, it doesn't change anything. Multiplication is commutative. Okay, so from here plus this time we have e to the power minus st times e to the power minus 80 times dt. Now we work on the base because we have same base, so we use indices here and then we add the powers. So from here we take our 1 out of 2 integral of 0 to infinity. Then we pick one of the base. Let's work on this side. Then we factorize t out. We are left with negative s and a. But watch very carefully. I'll bring the negative out into bracket s minus a, bracket close. I'll multiply by my t. Remember that this time this will give us negative st because we have t here. And this time this will give us plus 80. Remember, you always do it this way. Always start with s. That was the reason why I started with this one. I didn't start with this. For the sake of those of us that have problems, always start with s minus a. Start with s minus a or s plus a, depending on the factorization. Okay, so we go to this side, plus, we pick e, then we bring negative outside, s plus a, and we multiply by t. Okay, so that this time s, we have this part of the function, and then this time we have negative 80. Don't forget t is common, we factorize it out. So you multiply by your dt. In the next step, we integrate this and this. Now, how do we integrate an exponential function? So for those of you who are not aware of this, let me take you through. If I have e to the power, let's say at, let me use this function. The integral of this is giving me 1 over a e to the power at, or e to the power at all over a. Remember that a here is a coefficient of t. It can represent anything. So if I have something like negative 2 t, then the integral of this is negative 1 over 2, which is the same as 1 over minus 2 e to the power minus 2t. Okay, so we have here negative s minus a and t. So this is what we have, s minus a t. So this side of the function is the coefficient of t. So we repeat the same step by finding the integral of this, giving us 1 over minus s minus a, and e multiplied by e to the power negative s minus a times t. Okay, you raise it to the same exponent. Remember that I'm just using 1. I can also rewrite this as e minus s minus a times t, or dividing negative s minus a. Okay, so I prefer using this one. So we repeat this step here by integrating the function and introducing our upper and lower limit. Okay, so from here we have our 1 out of 2. We can bring a square bracket. We integrate this one. We have 1 out of minus s minus a multiplied by the same function minus s minus at, plus we integrate this side. We also have 1 out of minus s plus a multiplied by minus s plus a times t. Okay, we close this bracket and we introduce our upper and lower limits. Okay, in your next step, we introduce our upper and lower limit into the function. Remember that t ranges from 0 to infinity, so this side is equal to t, this is equal to t. So from here, we can rewrite this as 1 out of 2. Let's bring a curly bracket. We first introduce our upper limit. So this is it. We have 1 over minus s minus a e to the power negative s minus a into infinity. Okay, you do the same thing here, plus 1 over negative s plus a e to the power minus s plus a to infinity. Then we close this. So this is our upper limit. So minus, we repeat the same step, 1 over minus s minus a e minus s minus a into 0, plus 1 over negative s plus a e minus s plus a into 0. Then we close this. Then don't forget I opened a curly bracket here so that the 1 over 2 multiply the whole result. So we close our curly bracket. For the sake of those who are watching this for the first time, when I have the limit of a function e to, let's say, negative, let me use t, then whilst t approaches infinity, this result equal to 0. This means that when you substitute a very large number for t, the result converges to 0. You can check this with your calculator. Substitute a very huge number, 1 billion or 2 billion, and monitor the result. You see that your value will converge towards 0. So now, as t approaches infinity, this result is 0. 0 times this makes it 0. As t approaches infinity, this one is also what? 0. So all this side, we don't need it. 0 plus 0 is 0. Now let's move here. When we raise to 0, the result here is 1. So 1 times 1 over negative s minus a will give us the same result. This side, the result is 1 because a variable to the power 0 is 1. For instance, t to the power 0 is 1. So when we raise this to the power 0, we have 1. 1 times this, we are getting the same result. So we are left with only this function and this one. So we can rewrite that by having 1 out of 2 multiplying negative into bracket. Watch this carefully. There is a negative here because we have to subtract upper limit minus lower limit. So that is what I have here. Then we are left with, this is 1. 1 times this is giving us 1 over minus s minus a. Then we have plus negative, so this negative will affect this one. So I have minus 1 over what? S plus a. Okay, then we close our bracket. Times this. Don't forget this 1 over 2 is here. You can now use this negative to open the square bracket by using this to multiply this, use this to multiply this. So this is giving us 1 out of 2 times, now this time this we have 1 over s minus a, this is gone, plus 1 over s plus a. Okay, so now we need to take LCM for this one before we can multiply through by half. So let me take LCM here. The LCM here is s minus a, then s plus a. Now, s minus a will cancel this one. We are left with s plus a. Use it to multiply 1. The result is still s plus a. So s plus a into this is out. We are left with s minus a. Use it to multiply 1 plus s minus a. So if you didn't get what I just did here, we are just working on the LCM. So we took LCM, this times this, and we have s minus a and then s plus a. So if you want to work on this side, just pick the denominator, use it to divide this s minus a. Okay, this will cancel itself. You are left with what? S plus a. Pick s plus a, use it to multiply 1. That is what I have here. Repeat the same process for this one, and you have this. So this result will multiply 1 out of 2. Okay, so let me continue here. We can now expand the denominator. So we have 1 out of 2 times s plus a plus s minus a, or dividing s times s will give us s square. S times a we have plus as. A times s we have minus as. Then this time this we have minus a square. Okay, so this is what we have. Now we know that this a will now cancel this one because it's negative and positive. This will also cancel this. Okay, so we are left with s square minus a square. So we have our 1 out of 2 multiplying s will give us 2s dividing s square minus a square. Okay, now watch very carefully. Now this 2 will cancel this one, so you are left with what? 1 times the whole bracket, giving you 1 times s over s square minus a square, and that is your final answer. So the Laplace transform of Coshat is equal to s over s square minus a square. As simple as that. So I guess you got that. I wanted to manage the paper so that we fix everything on this same paper. So please pardon me for writing tiny. All right, so this is it for this particular question. The Laplace transform of this is this. Remember that a here is a scalar. So when I give you a question as cos 2t, then the result will be s over s square minus 2 square, giving you s over s square minus 4. And that will be your final answer. I'll take such examples, very simple ones, in the other videos for you to see. All right, thank you for joining me in this one. Please support this work. Hit the notification and subscription button and support this work. Thank you very much, and I'll see you in the next one.